So this is a pendulum problem, specifically related to the energy of the pendulum. It is a 1.4 kilogram pendulum. And what I want you to do is you're going to pause this video and you're going to draw this, noticing the heights and noticing that the beginning height, which is represented in blue, and the ending height are the same, and these two middle heights are the same, and they're halfway up, and this bottom height. And I want you to calculate the potential energy, kinetic energy, mechanical energy, and velocity for all 5 positions. So keep in mind that what a pendulum does is it starts from rest right here at the blue, and it swings through these different positions, and it ends at the other side like a child on a swing at the peak, and then it swings back. So the pendulum stops at the beginning and end, if you think about it, like a kid on a swing. So pause the video right now. Okay, presumably you're continuing to play the video because the class has basically reached consensus and they want to see the answers. All right, let's talk. So the potential energy is the easiest part. I recommend doing that first. You can get the potential energy for each position using potential energy equals mgh. That equation's on the board or in your notes. M is the mass, 1.4 kilograms. G is 10, and h is the height. The height for the blue is 0.6 meters. That's hard to read, but it's 8.4 joules. Sorry about the messy writing. 8.4 joules. Potential energy here, 4.2 joules. 0, 4.2, 8.4. Okay, the kinetic energy in the beginning, because it's not moving, is 0. And thus the total energy, also known as the mechanical energy, is 8.4 joules. The kinetic energy here, well, there has to be half of it over in kinetic energy, so it's 4.2 joules. And the mechanical energy is still 8.4 joules. Down here, all the energy is in the form of mechanical. So the mechanical energy is 8.4 joules. Sorry, all the energy is in the form of kinetic. Again, here, this position matches the other one. Over here, this position matches the beginning. In the beginning, the velocity is 0. But how do I get the velocity here? Well, I know the kinetic energy, so I have to plug into my kinetic energy equation. Kinetic energy equals, I'm talking about this velocity right here. Kinetic energy equals 1/2 mv squared, so watch what I do. I simply plug in the kinetic energy, 4.2, right here. 4.2 joules. This is the mass of 1.4. Take half of that, and it's 0.7. You're doing 4.2 divided by 1.7, then take the square root, you're just doing the algebra, and you get 2.45 meters per second. Do the same thing here, but for different numbers, 3.46, 2.45, and 0. Rewatch this video if you need to. To summarize, we had a pendulum with a certain mass, it swings through, its energy transforms into there's an exchange that's always happening between potential and kinetic, but the mechanical energy always stays at 8.4 joules. And mechanical energy is another word for usable total energy.